Hey guys, so today we're going to do a chemistry question. So what's the first step in any chemistry question? Read the question. So, determine how many of these molecules are polar. SO3, OF2, BeCl2, CCl4, and O3. Alright, this isn't really that hard, guys. We got this. Let's have a general overview of what we need to do. So, we will draw the Lewis electron structure, identify the partial charges and the bond dipoles, and use this to find the net molecular dipole, or the polarity. Alrighty, are you guys ready? Let's start with this first one, SO3. So, in the SO3, first you need to write the electron structure, right? So you write an S, so you'd start off writing this, an S, an O, an O, an O. You write your center electron, your center atom, then your outside atoms, right? Then you see how many valence electrons you have. Okay, so you have 24, 6 from the S and 18 from the O's. Then you subtract how many electrons were used in the bonds. So it's 6, 2, 4, 6. So 24 minus 6 equals 18. That makes 18 left, right? So 18 left. You put them on the outside atoms. 2, 4, 6, 8, 10, 12, 14, 16, 18. Am I right? 18. Now, you need to go ahead and realize that the S does not have an octet, right? The S wants an octet, though. So, you take a bond from here, and it's going to, as shown here, and it's going to go here, okay? So now the S is happy, right? So that's the electron structure. Now, look at the, we can forget this right now. That was just to show you guys how we came to this point. Now, look at the polarity. First, you got to look at the bond dipoles, right? So the O is more electronegative than the S, so it's going to 1 electrons more. So the O is pulling this way, pulling this way, pulling this way in electrons. Okay, good. Now, that makes the S, of course, partial positive, and the O is partial negative. So now the question is this whole structure polar or nonpolar? So, the question is, are all the domains the same? Now, you may be inclined to say, no, they're not all the same, because look, there's a double bond here with this O. Here's the trick, though, is because they're all O's, actually, this isn't a full bond. You have one bond here, one bond here, one bond here, and then a third of a bond here, a third of a bond here, and a third of a bond here. All right? So this trigonal planar, right, it has a trigonal planar domain geometry. This trigonal planar atom all has the same domains, therefore it is nonpolar. Okay, same reasoning, we're going to go with the next one, OF2. So you do the same thing, you drew your center atom and your outside atoms, right? So you have your O is your center, and then your F's. So you add up the valence electrons, so that's 20, minus 4 with the initial bonds here and here. So 20 minus 4 equals 16. You have 16 left. You put this 16 on the edges, as shown. 2, 4, 6, 8, 10, 12. Okay? That means you still have 4 electrons left. You still have 4 electrons left. So you place those electrons onto the center atom. Oh no, this shouldn't be there. There's a single bond here and a single bond here. You put the 4 electrons into the center atoms. Alrighty? So now, you look at the, you go ahead and look at the bond dipoles. There's a bond dipole. This is going to be, want to go to the fluorine. And this is want to go to the fluorine right here. Okay. Okay, very good. That'll make the O partially positive and the F partially negative. Agreed? Agreed. So now the question is this polar or nonpolar? Well, you have to look at it. What is the domain geometry? It has 4 domains, one here, one here, one here, one here. That makes it tetrahedral. Am I right? This tetrahedral, these two are different though. These two are different than these two. So the electron geometry, or the molecular geometry is going to be bent. Okay, it's going to be bent. And it's polar. It is polar. Why? Because the domains are not the same here. Okay, you got two lone pair domains and then 2 fluorine domains. Okay? I'm going to try to speed through this, the rest of this, so you guys don't have to feel like y'all are wasting time on this, because it's all really the same, it's the same concept. So you have Be is your center atom for this one, all right? And then you draw the initial bonds here for ClCl. You go ahead and add up the valence, that's 16, minus 4, 2 from each initial bond, that's 12. So you put the 12 on the outside. That's 2, 4, 6, 8, 10, 12. Alrighty? So next you got to see, are there bond dipoles? So there are, because this is going to want to go over here, and this is going to want to go over here. Now the Cl's are going to be partially negative, the B is going to be partially positive. But is this polar or non-polar? We'll look at it. The molecular geometry is going to be linear because the domains are the same. Ergo and therefore, it is not polar. Alrighty. Fourth one, more than halfway there, guys. The next one's CCl4, right? So you draw your center atom C and your 4 Cl's on the outside. Am I right? So then you go ahead and add up your valence electrons. That's 32 minus, and then subtract by the number of bonds. That's 8. That'll leave you 24. You put the 24 on the outside electrons. And this one's easy. You just literally just 6, 12, 18, 24. Alrighty. And that's going to be your loose electron dot structure. Now, the Cl is going to be more electronegative. So, slight dipole there, slight dipole there, slight dipole there, dipole over there. Alrighty. So the C is obviously going to be partially positive, and the Cl is going to be partially negative. Agreed? But is this polar or non-polar? Well, all the domains are the same. Okay? The molecular geometry is tetrahedral because there's 4. So all the domains are the same. Therefore, it is non-polar. Does that make sense? Okay, good, good. Pause if you need to look over that one more time. Last one's a little bit tricky, guys. Last one, just bear with me. It's O3, okay? So you draw your O's. Again, same concept. You have 18 valence electron, minus 4 from the bonds, so that's 14 left. You got 2, 4, 6, 8, 10, 12, 14. Alrighty? So this O, of course, is going to want to have, and you put, don't forget, you put that extra, you had 6, 12, and then you had 14 extra, left, 14 electrons left, so you put the last 2 right here on this O. But that's not enough to give it a valence of 8. So it goes ahead and makes a double bond here. But just like this one up here, the double bond is not a true double bond, it's a half bond. So you got a half bond here.